Hello Year 10. We have learned a lot of different techniques for sketching parabolas. We're not going to learn any new techniques today. Instead, what we want to do is apply what we have learned to some more practical problems. So this section of work today is called Applications of Parabolas. So quadratic equations and their graphs may be used to solve practical problems. And there's nothing else that we can really say except for jump into questions. Each question that you get of these will be slightly different, but the techniques that you use will all be familiar from what we have learnt in this topic. So the example here says, an 80 centimeter piece of wire is bent into the shape of a rectangle. Let x be the width of the rectangle. Okay, whenever it starts describing a shape, it is best if you draw yourself a diagram. So I'm going to draw it down here because that's the biggest space I've got to do this in. So here is my rectangle, and it says the width of my rectangle is going to be x, so that's going to go there. Part A says, use the perimeter to write an expression for the length of the rectangle in terms of x. So I need to know what the length of the rectangle is. So I've got a length there, and width there, width there. So if I wanted to know the perimeter of that rectangle, P for perimeter is going to be equal to 2 lengths and 2 widths, so 2L plus 2X. The question told me that the piece of wire that I'm using to make this rectangle is 80 centimeters long. That 80 centimeters then has to be the perimeter. So let's sub that in here. 80 equals 2L plus 2x. And I've been asked to get an expression for the length of the rectangle. That means I want to make L the subject of this equation. So I want to leave the 2L here, and I'm going to subtract the 2x across to the other side. So 2L would be equal to 80 minus 2x. Now to get the L completely by itself, I now need to divide by 2. So L equals, and I divide each of these terms by 2. 80 divided by 2 is 40, and 2x divided by 2 will be minus x. So there it is. That is my expression for the length of that rectangle in terms of x. So the length is 40 minus x. Part B, write an equation for the area. Okay, we were talking about perimeter before. Now we've been asked about area. Write an equation for the area of the rectangle in terms of x. Now to find the area of a rectangle, you normally say area is equal to the base times the height. Now the base of my rectangle is L and my height is the x, but I actually don't want to use L for my length because I've just worked out that L is equal to 40 minus x. So I'm going to use my base and my height as those two that I've just highlighted there. I want to times those together. Now, that will give me A for area equals base times height is going to be the x times by the 40 minus x. You could have the 40 minus x written first and then the x second, but we normally like to have a single term like that at the front of the bracket. Now it's going to be easier for us if we expand this out, so let's do that. A equals x times 40 is 40x, and x times minus x is minus x squared. Okay, next part, part C. Decide on suitable values for x. Okay, now because this is a practical question, not all solutions, not all values would be reasonable. For starters, we are talking about a shape. We can't have a shape that has negative side lengths. So the x and the width, the length and the width must both be positive numbers. And that also means that the area has to be a positive number. Okay, so that's my suitable values for x. I know that x has to be greater than 0 because I know I can't have negative side lengths. And that also means that my area must be positive. So for my area to be positive, I've already said that x has to be greater than 0, but the thing that I'm timesing it by would also have to be positive. My length also has to be positive. So that's actually a second part to this. So it's like an or. X has to be greater than 0, or the 40 minus x has to also be greater than 0. If I solve that little inequality, I'm going to subtract the 40 across. So minus 40 over here. Divide by a -1 means I need to turn the sign around, and that will become a positive 40. So it means I actually have two criteria here. X has to be greater than 0, but it also has to be less than 40 for this rectangle, dimensions of this rectangle to actually work. So to write the solution, we write the x in the middle. We put less than signs on either side of it. My x has to be between 0 and 40. That's the best way to write that solution. Part D, sketch the graph of A versus X for the suitable values of X. Okay, so we've got our suitable values between 0 and 40. So we don't need any negative values because we know they're not going to work for our equation. So X is going to be here. Our Y axis is actually the area that we're talking about in this problem. And we're going to be looking between 0 and 40. I'm going to put a few marks in here to space this out. 10, 20, 30, 40. I'm going to put 40 there. Okay, so my graph is going to be, I want to look between 0 and 40. Where are my intercepts going to be? Because I already have a factorized version of my equation, so see back here in part B, there's my factorized form of my quadratic. That's telling me if I use the null factor that x is equal to 0 and x is equal to 40. They are my x-intercepts down here, x equals 0 and x equals 40. Then I need to find, well, normally I'd want to find my y-intercept, but I've actually already found it here. It's already at 0. And I want to find my turning point now. The turning point is going to be right in the middle of those two intercepts, so it's going to be here at 20. And all I need to do is sub 20 into my equation to find out what A is. So using my formula, A equals x is 20, so 20 bracket 40 minus, not x, 40 minus 20. Okay, we type that in our calculator and we get 40, take away 20, we get 400. So there's my turning point. You can write it here if it makes it easier to see it. My turning point was x is equal to 20, and what we'd normally call our y value, but in this case is our area, 400. So again, you might want to choose a scale to go up here, 100, 200, 300, 400. My turning point is going to be here, which means my parabola looks like, oh, a bit wobbly, looks like that. Okay, part E. Use the graph to determine the maximum area that can be formed. The maximum area is my turning point. So I've actually already done all the working out over here. My maximum area was when A was equal to 400. If you want to do the working out, that was the working out that I did there to find that area. Part F. What will be the dimensions of the rectangle to achieve its maximum area? The dimensions of the rectangle, we already know that the x value, which is the width, is 20. Okay, so let's write that down. the width will be equal to 20 centimeters, and the length, remember way back at the beginning that length was equal to 40 minus x, so I would need to go length is equal to 40 minus the 20, which is also going to be equal to 20 centimeters. So it turns out that this shape is actually going to be a square when it has a maximum area. Okay, so that's just my one example for applications on parabolas, and you can now have a go of exercise 9F.